Yeah, it sounds
crispy.
Crisp as. All right.
Sure.
G'day, folks. Welcome to the Layman's Podcast, where we talk to extraordinary people from all walks of life. My name is William Kinsey, and here with me is Lockie Gardner. We're on an absolute warpath of guests at the moment, so if you think you can keep up with us, you can follow us on Instagram at Layman's Podcast, and also on Facebook.com/Layman's Podcast. If you enjoy the episode today, please don't forget to subscribe to our YouTube channel. It's free, and we love the support. If you don't have a YouTube account, then get your life together, dude. I won't waste any more time. So today we're sitting down with Professor Navid Moheimani, who is the Director of the Algae Research and Development Center at Murdoch University. How are you, Navid?
I'm well, and you?
Yeah, very good, very good. So I came across you, obviously, as I said before, I came across the Australia 21 report, which is a think tank.
Yeah.
I guess, how did you sort of get involved with that? Obviously, with your background in phycology, but how did that all sort of come about?
So phycology is the studying of algae.
Yeah.
So what we do to find out what the algae does and the advantages of the algae. So I'm an applied phycologist. So trying to find out what we can do from the algae to take it to the industry. So I mean, this is an interesting thing, is that nobody in this state knows that the largest algal farm in the world is based in Hot Lagoon, which is just 4 hours from Perth, north of WA.
Oh, really?
Yeah, which is producing a product called beta-carotene. So this product is the product that you can find in carrots, but this particular alga, which is producing this product, has this product inside of it thousands of times more than the carrots. So that's why we've been growing it, since 1970s. Interestingly, this plant up north in Hot Lagoon produced the bulk of natural beta-carotene in the world. This was established by Michael Borowiecka, which was my PhD advisor, and his wife, Michael and Leslie Borowiecka. They established this plant in 1970s, and it's been keep going. And since then, we have been involved with algae and how we can take advantage of the algae. So there has been a lot of interest on biofuel, if you remember a few years ago. And there's still interest in the biofuel and biofuel production because the fuel is running out. And we continue working on it. Having said that, the cost of fuel is extremely low. So we're talking about the product which is around $1.50 a liter maximum. So we think higher value products got an easier market to enter to. And we're also working very closely on the wastewater treatment and this area. And this is how we got to the think tank Australia 21 and what we can do with this algae and the future of the algae and applied phycology in Australia.
So if we could break down the report that Australia 21 produced in collaboration with you and quite a few other people in that background, what was the crux of the report? What were they trying to establish and communicate to the wider public? So
where can we go with the algae, which is typically, as I mentioned, biofuel is the typical way to go. The other very interesting aspects of using algae is the wastewater treatment. And this is especially over east in Great Barrier Reef. There is a lot of effluents, which is finding their way to the Great Barrier Reef. We don't want to see that. The algae can be actually a process to remove these effluents.
Is there a nutritional side to it as well?
Absolutely. So when you grow the algae on the effluent, it doesn't matter where that effluent comes from, as long as there are some inorganics in it. The algae which grows can be used as an animal feed. It can be used as a fertilizer. It has a lot of properties that can be used in the industry.
So even like as dietary supplements?
Algae has been used as a food for human. If you especially go to Southeast Asia and to the Southeast Asian culture, it's pretty much every meal you have algae in there. You don't have the small algae, you don't have this bigger algae. We call them microalgae or seaweed. In sushi, for instance, you have it.
I've heard of vegans using algae as a replacement for fish oil.
That is
DHA,
correct.
etc. Yeah.
So to be honest, one of my dream in my life, and I don't know if we're gonna get that or not, but it's that we're gonna have. I'm hoping that in the Western culture we're gonna have a large use of algae in the food.
Yep.
I mean, nutritionally they're fantastic. I mean, some of them can easily replace a lot of protein that we take from the animals. It's just it can be done.
Why do you think there's a lack of the consumption in Western cultures? Is it a lack of accessibility to that, or is it just like a mental thing? Like, oh, it's gross.
I think it's a combination of both. Yeah. I mean, to be honest, if you go back to the culture in Southeast Asia, they started using it because they had to find the source of protein. They had to find the alternative sources of protein. Yeah. In Western cultures, we didn't have this issue, so we always had other sources of protein that we could go and reach and have our proteins consumed through those sources. The reality is we are running out of food. I mean, the planet, we're having more human beings on this planet. The population is increasing. We need to find the source of food for them, and the algae can be potentially a source of food for the population.
When we're talking about algae being used as a food source, is that now, correct me if I'm wrong, but when we're talking about producing biofuels using algae, we're just skimming the oil, essentially. So we're still left with the actual algae product. So you basically end up, through the process of creating biofuel, you end up with the biofuel, but also as a byproduct of that, the algae as a food source as well.
That can be done. That can potentially be done. A little bit of issue with the biofuel is the size of the production. Mm-hmm. So if you want to be significant, so for example, we did some modeling a while ago looking at if you want to produce 10% of 1 day of Australian diesel production, you need to have an area of around 600 hectares or 700 hectares of land.
Yeah.
So that size, look, it's never been done. I mean, the production of that size has never been done in the world. So it's a challenge of getting to that size. The product which we can convert to the diesel is the oil inside of the algae.
Yeah.
So we can get the oil outside of the algae, and there is a very easy process called transesterification, which we can convert the oil to the product which is called biodiesel.
Yeah.
This biodiesel can easily replace the diesel which is in the engines. Yeah. Mm-hmm. Challenge, as I mentioned earlier today, is the cost of production. So make this cost effective is the biggest challenge that we have right now in the industry.
So it requires heavy innovation.
So we need to increase the productivity of the algae and reduce the cost of production. Yeah. Mm-hmm. That has to be done.
Yeah. So that's sort of the challenge out there for the future scientists. And
so this is one of the biggest headaches. You know, a lot of these gray hairs that I have, the results of this, this challenge. Having said that, I mean, even in the process of treating wastewater, we are collecting the inorganics from the effluents, producing the biomass, that this biomass, whatever is inside of that biomass is a renewable energy. Yeah. So the food that we eat is a renewable energy. It's in the form of sugar or lipids or in the form of protein. So we are converting the waste to the energy, but it's a food energy instead of, for example, being fuel.
Yeah. So I guess another significant factor as well with large-scale algae production for biofuels and as a food source is also the fact that CO2 is like an essential ingredient. I've heard there are some instances where people have suggested placing now these. So are they called raceways? Is
Raceway
that
ponds,
the sort of standardized production of algae at the moment, which is like streams for anyone listening that doesn't understand? Or maybe you could explain what a raceway is.
So raceway are literally a trench in the ground, and there is a small paddle wheel on it, which is turning the water. This is one of the cheapest ways of mass cultivation of algae.
Yeah.
Yeah.
And so attached to those raceways as well, do you have like a column, I think, that was designed to, maybe we've innovated further past that, but it was initially designed to remove the oxygen from the raceway. and then also to condense the algae down to what you could actually extract from the raceway. Is that
So what you just mentioned, you said carbon dioxide. Yeah. So carbon dioxide is a greenhouse gas.
Yeah.
It's causing a lot of issues. I mean, it's not everybody's aware of it. It's a huge issue nationally and internationally. So if we remove the carbon dioxide addition from the algal culture, we literally can lose the productivity up to 80%. So it's extremely important to have the carbon dioxide. So this is beneficial to what we do. On the other hand, the process of photosynthesis, which the algae convert the carbon dioxide to sugar, produce oxygen. Which is that oxygen is the reason that we human being on this planet. So the oxygen which the algae produce. But this oxygen is toxic to the algae. So that oxygen stops the process of photosynthesis. To date, we haven't found a way to strip the oxygen cheaply enough from the culture, so we can remove this toxicity of algae. There are ways, and we can bubble nitrogen gas through it, but they're all fairly expensive methods.
So that's challenge number 2 for
that's
future
challenge number 2.
scientists.
I think that is actually an engineering challenge. So that is why I work very closely with engineering at Murdoch and at other universities to find ways around all these challenges.
What are some of the emerging possible solutions that you guys are working on?
So one of the novel things that we do is, you see, if you want to mass produce fuel, you need to grow the algae. So the oil is inside of the algae. Then you need to collect the algae, what you said, harvesting, get them out of the water. Then we need to crush them and open them up, so have access to that oil.
So with might interject, with removing the oil from the algae, is that through either the use of solvents or sound waves? Is that the 2 primary methods of?
The most typical way right now is to use solvents. So today the cheapest method is to use solvent. There are other ways of breaking up the cells, like sound waves, like microwave, etc., that you can open up the cell. But at the end, we need to somehow get inside and get that oil out, and the solvents are the easiest way of doing that.
That's similar how vegetable oil was produced.
That's correct. Very, very similar to how the soy oil, for example, produced.
But more efficiently.
More efficiently. That's correct. That's correct. Look, I mean, the productivity is, it's just, you cannot compare the algal productivity with the soybean productivity. So there is a particular alga, this algae, and we don't know why they do this. They spit out the hydrocarbon. So the hydrocarbon is fossil fuel. Right? Every algae produces triglycerides. So triglycerides is the same fat that we produce. These particular algae produce hydrocarbon. It's a long chain hydrocarbon. It's literally the oil that you get in the oil drills. And they put it outside of the cell. So we have been working on developing a system to, instead of killing the cell, going to those colonies of these particular algae and milk the hydrocarbon. Instead of grow, kill, harvest, we just milk the hydrocarbon. We've been fairly successful. I mean, that's we call it a non-conventional biofuel for production from algae. But it's still also got its challenges. I mean, we've been working on this particular project for the last 5 years, and I think we're gonna go for another 5 years to be able to take it to the industry.
Great, that's fascinating. Wow, I wanted to talk about biophotovoltaic devices.
That's another. That's another very interesting concept that we are working on. I mean, it's not only us working on this, there are other few groups in the world working on this. So you see, algae converts light, take up the carbon dioxide, and produce sugar. That sugar then later on being converted to the other products. The algae, there is a reason that they're green. All right, the reason that they're green is that they can absorb all the lights except the green light. So they reflect the green light.
That's basically how grass.
That's exactly correct. So you see the grass are green because they don't take up the green light. They reflect the green light. They don't like it. So they cannot use it. So they reflect it. They get rid of it. So if we had a plant which could use all of the lights, it would be black. It would be literally black. So we don't have them. Yes, because I mean, this is evolution, and there is nothing I can do to change it at this stage. Maybe in the future we can do this, but Right now we cannot. So we have been working on the process. So here it is a portion of the light that the plants cannot use. The portion of the light that algae can also not use. So we've been working on the process of developing a system which we put it on the surface of the culture. It would take up the green light. It would also get rid of the infrared and the UV, convert those to electricity, and then remaining of the light gets to the algae. All right, so the electricity that we generate, we can use it to run the cultures, and the other advantage is the heat which we get from the infrared. We removed it also from the system, and in WA, one of the issues we have with the cultivation of the algae is the heat.
Yeah,
because we have a lot of heat, especially during the summer. So this is also one of the innovative projects that we are working on right now.
Sounds super sustainable.
It is. So it is. The work is done with a group at Edith Cowan University with Professor Algae, and these guys. I mean, I'm not a physicist, so those guys done a lot of very good job on the physics side of this.
Yeah. How significant is the energy lost currently when we talk about not being able to utilize the green?
So I really don't like this
Colorway.
question. Yeah. So this is one of the questions I ask my students when I teach psychology at the university. I said, look, you see, the solar panels, they keep getting better. They're around 15, and right now potentially we can get them up to 20% efficient. The algal efficiencies, the maximum that we achieved is 2%. Yeah. So. And again, this is evolution. There is not much we can do about it. There are lots of limitations that we are dealing with. But to date, the best photosynthetic efficiency we achieved is 2%.
Yeah.
So whatever we do is we're trying by finding simple ways, like what I just mentioned, using light more efficiently to increase this efficiency.
Yeah.
Or channel some of the lights that we cannot use, so we use the efficiency of the light the other way, and combine this with the algal efficiency to get this process more efficient. Because our estimate is right now the biofuel from algae costs around $4 a liter.
Yeah.
We get 2% efficiency. If we can cheaply increase this efficiency by 10% instead of 2%, and this is the maximum potential efficiency that we can achieve. That means that instead of $4 a liter, we can reduce this cost of production to around $1 a liter or even less. That would then resolve the issue of biofuel production.
Okay. So challenge number 3.
Yeah, I mean,
We'll have like 100 by the end of this.
Yeah. I mean, if it was easy, there wouldn't be no need for me to work on it. Yeah. I mean, that's.
So like anything, it's just the trying to justify it economically.
Economics.
It always comes down to
economics. I mean, that is one of the issues with science, though. I mean, we have to make sure that the process is economical. If the economics don't work, you cannot raise fund for it. If you cannot raise fund for it, you cannot take it to the industry. If you cannot take it to the industry, you cannot scale it up. It's a good research.
Yeah.
It's a good research. And there's nothing wrong with doing a good research. But at the end of the day, a process like what we're doing, if we cannot make it economical, it's never going to see the light outside of the lab.
The highest goal sounds worth it, because you mentioned it before, but you can use it. You can use it for cars, right?
Absolutely.
It can replace diesel, etc.
Jet fuel. I mean, that is
without much of a change in infrastructure.
No, I mean we can literally produce a jet fuel from algae, and there is one of the most interest from the industry.
So if I'm going to probably take a while to sort of figure everything out, but when we get to that point, and I believe it would, humans are capable of quite a lot. That would be game changing.
Absolutely,
because it's a completely renewable thing.
Absolutely, I fully agree. If we can make the price low enough, it would easily replace a big bulk of the fossil fuel that we're using.
Yeah. Even in combination with solar energy and electric cars, like if you have all like 3 or 4 different renewable energies going, it'll just be exponential. Just
correct. Agreed. Yeah. I agree. I cannot agree more. I think we need to be going sustainable. Absolutely. I think we need to be sustainable. for my son's sake, I mean, for the future generations, I mean, I don't think we're gonna suffer in this generation. We're gonna suffer, but the future generations they're not gonna have enough fossil fuel.
Yeah.
I plan to live a long time too, so I would.
Yeah. I'm sure you would.
Our generation, right now, it seems to be the tipping point where we're sort of maybe one of the last one or two that might enjoy a relatively stable world in many
Barrier
aspects.
reef,
Yeah,
right,
but
yeah.
for sure, I think this elaborate house of cards that we've constructed with our consumption of resources and quite irresponsible
In
consumption.
a very short period of time.
Yeah, but I mean, speaking of resources, when you think about it, we live in a state which is perfect for what we do.
Yeah.
Literally, this is one of the best places in the world for mass cultivation of algae.
Yeah.
We have access to unlimited source of water, which is Indian Ocean.
Yep.
Yeah.
Okay, we've got plenty of non-agricultural land that we cannot use it for anything else. All the coast from here all the way up to Karratha, it's unusable for pretty much anything else.
Yeah.
And this is something that we can use it to produce food for a lot of places in the world that right now they don't have food. I mean, we can literally export food to Africa. I mean, there are lots of people suffering from hunger. I mean, there is no question about this. So Australia can become one of the locations of mass producing food and protein for the worldwide. I mean,
That's an interesting point about utilizing non-agriculturable land. Is someone mentioned when I was doing some research yesterday that the algae industry has the potential to compete with the fossil fuel industry without having to compete with existing agricultural industries. So, I mean, it's sort of everyone's
in
friend.
the right way.
Watch out which side.
So I mean, the main advantage of algae is that we don't need fresh water.
Mm-hmm.
So we have actually developed a process that you don't need to have a drop of fresh water in the process of mass producing algae. I mean, not just for biofuel, but also for other high value products. I mean, the algae that we're growing for beta carotene, that is growing at very high salinity. I mean, the seawater salinity is 3.5%. This alga grows at 20%, almost 10 times of the seawater salinity. Not many other organisms can do that. So this is also an advantage of algae that not a lot of organisms can have. I mean, the higher plants, you have to have fresh water. You also, as you rightly said, you also have to have the agricultural land. For these guys, you don't need that.
Yeah. So while we're sort of talking about utilizing algae production on land, this is something we spoke about earlier before the podcast. Could we maybe talk a little bit about omega for people that don't understand it, and also some of the reasons that you discussed earlier about why that isn't possibly feasible? So I guess for people that don't know what omega is in the algae production industry, could you describe that?
So in my understanding, the omega process came out of NASA. So they funded a project to look at treating wastewater using algae. And the process was to build algal farm on the water. So they put the algae in some sort of plastic bags and put the effluent in there. And the algae was they were capturing the effluents and the nutrients from the wastewater. I think this project is stopped now. I don't think they actually managed to raise the fund. And one of the challenges was, I mean, if there is an issue with the leakage from the bags, we put the effluent in there and they open up and it gets to the water bodies, what would be the consequences? There are other groups, especially in Korea, that they're using on water cultivation system because they don't have the land available, but they're using natural nutrients from the water. So they've built a system that those membranes would allow the nutrients to penetrate to the culture. The growth rate is fairly low compared to what we get, but that process works because they're taking up the nutrients from the water.
As opposed to
adding the effluent,
wastewater.
That's correct. Look, in a country like us, in a location like us, in Australia, when we have access to the land, non-agricultural land, my suggestions would be do it inland instead of going on the water. The other thing is our coast is not very calm. So if you have in a place that is not calm and you get lots of waves, You just need to have one of these reactors turn over, and then you may end up with an environmental issue.
So, talking about the wastewater, the potential for that to harm the immediate environment around the Omega structure, I assume that the effects that the wastewater would have on the environment, where it would currently just be pumped out into the ocean versus cultivated inside the Omega, are compounded through that process? Is that why there's a real pushback?
That's what they were trying to do. They were trying to use those systems in the rivers and for the algae to take up the effluents out. Mm-hmm. So if in principle that's a good idea, but obviously something didn't work that they stopped it.
Yeah, so that's the big limiting factor there, because I know a lot of the other aspects about the Omega, like on a superficial level, seemed like promising. You know, they boasted that you could it would provide a backdrop or a foundation for aquaculture, biodiversity. You did mention the waves could be harmful, but I guess depending on the environment, they suggested that the waves would allow mixing as well if it wasn't maybe too substantial.
One of the advantage of going underwater and cultivation underwater is that you don't need to have potentially a mixing system in your culture, in the culture. But as I mean, at the end of the day, it's a pros and negatives of a potential process. That's what you choose to do. It was a good research, but
So is it maybe? Do you think that there was maybe hope there? It's just that they were unfortunate not to get enough funding to kind of overcome those problems, or
potentially there. I am aware of other systems also on the water in Malaysia that people trying to develop, but as long as there is the process is economics of the process works, and they don't create any damage in the whole process to the environment, I think there may be in the future for them.
Yeah.
Just a quick question. How many years has algae been evolving, or at least in its most simplest form?
I mean, you mean the industry or the species?
A scale of billions.
Yeah, I mean, they've been here way before us. Yeah. I mean, so these guys, cyanobacteria, which are predecessors to the eukaryotic algae, they've been here right way before any of us came on this planet. Long time ago. They are the reason that the oxygen's been generated in the atmosphere.
Yeah, which was originally toxic to...
Yeah, that's correct. Yeah. So the planet didn't have the oxygen. The cyanobacteria came and they started pumping the oxygen to the atmosphere.
Well, thank you, algae.
Yeah, that's correct.
They did us a real solid, so now we need
They gave us genders as well.
Yeah, that's true.
Yeah.
Oh, no, not anymore, though. There's no gender anymore.
Yeah. Have you, obviously in your study, have you looked into the very early existence of algae in terms of maybe it being the a catalyst for life on this planet as well? Have you sort of gotten deep into that? Like
they are.
I mean, this is uncharted territory for me, but is it essentially, where we originated from, where all life on this planet came from was initially very simple.
All of the land plants, they all evolved from one group of algae.
Yeah.
So we call them chlorophyta. Yeah. So there are various groups of algae through the evolution. I mean, that's why it's been millions of years of evolution that ended up with different groups. And that's also one of the other challenges that we have, is because you see, we've been growing corn for the last 6,000 years, and we master in growing corn. We also been growing bananas for a long time, or apples, etc., etc. But the whole algae industry is 60 years old. And we're learning. I mean, we're learning very fast and being very efficient. But going from one alga to another alga, when it comes to the cultivation, they're different beasts. Yeah, they're different animals. They're different organisms.
Yeah, they're not just cloned like corn and bananas.
No, they're not. So, and genetically, one alga to the another alga can be more different than bananas and elephants when it comes to genetics. Yeah, I mean, they're extremely diverse. But again, that's what makes my life very, very interesting.
Yeah.
To try to mass culture these things.
Yeah.
Wow.
So, taking that into consideration, do you have much any beliefs about like how life started as well? Seeing as though we know that it was a catalyst for existing life on the planet, but if we just go a little bit further into maybe unknown territory, like is that something that you sort of touched on in your research and then maybe theorized about?
That's completely outside of my research field.
Yeah.
I mean, there were bacteria, then there were cyanobacteria, then there were eukaryotes.
But at some point, it's just, we're missing it's like lost footage at the beginning of the film. We sort of don't really.
Yeah,
At some point, we don't know.
I don't feel comfortable to get to that.
Yeah, you show a lot more straight than us. We theorize wildly.
Yeah, we go off.
Maybe outside of this, yeah.
Yeah. I know there's a crazy theory about, I can't remember what the name of it actually is, but it's basically about the idea of life being seeded on planets through meteorites. Panspermia.
I think it's a pretty controversial topic.
That's a wild one.
Yeah.
No comments. I don't know. Anything can be possible. Anything can be possible.
If there was, I guess, turning this into more of a casual conversation, if you could just maybe, if you had to jump on board with any kind of theory or any just crazy pub talk ramblings about how life originated, what would be your inclination or,
Evolution.
Yeah.
Evolution. So, it happened, and I think we know it happened. I mean, it took a long time, but we are the outcome of evolution. So, yeah.
Well,
I can get on board with that for sure.
Just a lot of time.
A lot of time. Yeah. And patience.
Yeah.
Non-conscious patience.
Yeah.
Single cells probably went like, let's get to humans already.
Do you get excited when you hear about other planets that, they always talk about the Goldilocks zone or these habitable zones where the conditions for the existence, like, if you have water and CO2 and the right temperatures and various other factors that would be a precursor for the existence of algae and various things like that. Do you get excited when you hear about these planets and you think, well, based on your knowledge, is it possible?
I mean, I don't think we have found any other planet yet, but I think it would be highly unlikely that there's no life somewhere else. I mean, it must be.
But given the right, all the right factors there, I mean, you would lean more towards, if you were ever able to, in a perfect world, explore that planet, you would be leaning towards the fact that, well, there could be something here, if we were able to get a probe.
Possibly. That can be possible.
Yeah, that's very exciting.
I'm sure there's a planet somewhere full of algae.
Yeah. Oh, God, yeah. Sure.
One can hope. One can dream.
Yeah. So let's talk more about yourself. So where did you first study and how did you actually get into what you study now and your background?
So I was born and raised in Iran. I did my undergrad and my master's there. And I moved to Australia in 2000. And then when I was in Australia, I was looking for a PhD, and I saw an advertisement for using algae to remove carbon dioxide. And that's interested me. And then I applied for that scholarship with Michael Borowitzka at Murdoch University. Mm-hmm. I joined him, and the rest is the history. I've been here since then.
Yeah.
Wow.
Oh. And Michael, I believe, is retired now in Tasmania.
He moved from here to Tasmania.
Beautiful place.
Yeah.
Yeah. Wow.
I don't know if there's any algae.
There are lots of algae there.
So a point I wanted to make as well about the biophoto. Oh God, I can't do it.
Photobioreactors.
No, the
Photovoltaics and photobioreactors.
Yeah. So I noticed some research there that suggested that it possibly could have early applications at the current level of efficiency in Africa, where there's less of a energy requirement and it could be more useful.
That's
at that
correct.
sort of level.
That's correct. I mean, I think we need to start thinking about helping Africa, and there are processes for producing food there. And you see, I'm not sure if you're familiar with the product called spirulina. So this is a spirulina. So
Spirulina?
It's spirulina. Yeah. So it's
Is that the superfood? Or is
no, it's
that
actually
spirulina?
it's spirulina. It's a algae that you can get it in the health food shop. So this is it's actually a cyanobacteria, which is you can use it as a human food. And if you go back to Aztecs time in Maya's time, I mean in South America, people have been harvesting this from naturally blooming lakes and using it as a food. I mean, there has been talks and discussions about mass producing this in Africa. There are parts of Africa you've got water available, so mass producing that as a food. These closed photobioreactors with photovoltaics are reasonably more expensive than open ponds, so it potentially makes more sense to go in the first instance with the open pond systems for mass culturing food for the population. And this is something that which has been done in India, for example, or in Burma. And I mean, this is this algae is being produced as a food.
What makes a spirulina nutrient dense? Is it the omega-3 or the polyphenols in it?
It's
or?
very high in protein.
Protein.
Yeah, it's
protein,
very high in
right.
protein. It's around 35 to 40% protein content.
Okay, right. That makes sense, yeah.
So I've also...
you go. No, I was about to say I've used up everything else.
Oh, yeah.
All the other research I've done.
Also talking about like farm runoff as well.
Yeah, so again, it goes to the wastewater treatment. So during the last 4 or 5 years, we've been working very closely with the pork CRC, treating the piggeries effluent.
Mm-hmm.
And this is something which interests me a lot because there is a lot of inorganics in those wastes, which is the algae is a perfect organism to take those on. And we have also a lot of agricultural runoff that also contains organics and inorganics that algae can be used to take up those products.
Yeah.
I mean, we can use microalgae, which are the small one, or macroalgae for the process, and it's been done. We use mostly microalgae, but the guys at the James Cook University, especially, working very hard on macroalgal wastewater treatment. And again, the product, I mean, the advantage of this is that you get clean water, so you don't contaminate the nature. And the product is something that we are looking very closely to this, if we can use it as a fertilizer, for instance. I'm not sure if you heard of Rich Grow. So
No.
So it's a fertilizer company that we are working very closely with them if we can use the biomass as a fertilizer. Because so this fertilizer, then it would give you organic food instead of a lot of fertilizer in the market is inorganic. Yeah, so using chemicals. Yeah.
They can potentially kill plants at the fundamental level.
Not necessarily killing plants. It's just
like
where they're coming from. I mean, a lot of fertilizer comes from burning fossil fuel. Yeah, so again, bypassing this, if we can produce, and organic food is better for your body.
Mm.
Yeah.
So my understanding is with the dried algae as well, that can be burnt for heat and electricity.
That can be done.
Does that produce any byproducts that are harmful, or is it virtually...
I mean, I would not recommend that because you've got coal. I mean, that would be the same as burning coal. Yeah, I mean, if you've got the product that you can use the product. I mean, inside of the algae, you've got omega-3, omega-6, as you mentioned. I mean, these are the fish oil, yeah? Mm-hmm. So if you've got, why would you burn it?
Yeah.
Why not get that to the,
So that's like a lesser sort of... It's an application, but it's not considered to be a...
Yeah, I mean, a better way of this, if you've got a spare biomass that you don't know what to do with it, just anaerobically digest it. It's a well-known process that produces methane. Methane is still gas that you can burn. The gas is more efficient, less, and it's more environmentally friendly.
Mm.
Yeah, again, I mean, the thing that stands out to me about all this is just the cyclical nature of it all.
Yeah.
You know, all around just the usage.
Yeah, and using natural products. Yeah, I mean, this is also what we're trying to do, is just using what what the nature is giving us
Yes.
to produce that in our benefit.
Yeah. That's because that's probably what's caused a lot of the problems that we found ourselves in now, pulling ourselves away from nature
I think
too
so.
far. Yeah.
Yeah. So what you supervise a handful of PhD students, is that
Yeah,
Is that
so
correct?
one of my role is to train PhD students. So I've got students in pretty much whatever we discuss here. I've got a PhD student.
Yeah. Oh boy. So some, I think a couple of them actually recently won a competition, or that was quite significant.
Yeah, so two of my students went to BASF competition. I think it was 2 years ago, and they won it. It was
Okay.
for the photovoltaic combination and algal production. Yeah.
Yeah. So what was the specifics of what they were doing and with the competition itself, and could you elaborate a little bit on?
So I'm not sure about the other projects, but what these guys did was what I mentioned earlier today, is the combining of the algae systems with the photovoltaics.
Okay,
And they also bring the milking to that too. So it was the work of two of my PhD students. One of them is
That's
finished
excellent.
right now. The other one is about to finish.
Yeah. Wow. Oh my goodness.
Have we talked about the frequencies?
Frequency.
To get the oil out using sound.
We touched on the sound waves.
So so it's one of the ways of breaking up the cells.
Yep.
The ultrasound can be used to break up the cells.
Yep.
Yeah. Yeah.
That's a fascinating process to me.
Yeah.
Yeah. Is that essentially sonoluminescence or some? No, that's quite a different process.
I think it's
isn't
called
it?
ultrasound.
Yeah.
That's,
So I'm thinking of sonoluminescence being quite a fascinating process where bursting bubbles underwater using sound waves can produce light.
wow, I don't know.
It's
I should go and
very
Google it now.
interesting.
Can reduce light.
produce
produce
light.
light.
Yeah.
Wow.
Yeah, I don't think they quite understand how it works yet. They're just like, oh, this is a thing that happens. All right, cool. But
That's a good thing about your job. Yeah, I mean, you get to learn these sort of things.
As laymen, we open ourselves up to everything and anything.
That's cool.
yeah, we kind of throw ourselves in the deep end, and I think part of that is being comfortable. We've kind of developed this whole layman's brand as like a safety net for us asking the stupid questions.
Oh, there's no stupid question.
That's what I like to hear.
There's no
yeah.
stupid question.
So we jump in the deep end, in areas where we're fascinated, but our knowledge is very limited, and then just try and dissect information and understand it, and it's been a very fun process so far.
Because none of it's locked away. All you have to do is just reach for it. It's like,
That's correct. That's correct.
Yeah.
The whole premise of it was, I originally got into podcasting as a listener and a viewer, and just found that, like, I guess in the same way that Michael Borowitzka would have been a mentor for yourself at Murdoch, you maybe in your lifetime see a handful of significant mentors that guide you through life, but podcasting opens your world up to some of the most successful and brilliant people in the world, and it's right there. So
I mean, that's a great way of introducing the knowledge to the general population, and that's extremely important, because we want to make sure that the link between the science and the general public is there. We want to make sure that we just don't do the research in our labs and it just stay there. We want to make sure that everybody's aware of it.
That's like that carriage metaphor we were talking about in the last episode.
Oh, yeah.
Yeah. Where you can't talk to the people in the first carriage, so you think you're an other to them.
Sure.
And you start to have all these wild ideas about them, which is why I think a lot of anti-intellectualism, anti-science comes from. You can't actually have a direct communication with people doing the science. Yeah.
One of my job is trying to make sure that this is simple enough for everyone. I mean, we regularly have students from the high schools coming and visit us. I mean, just making sure that everybody knows what we're doing. That's extremely important to us.
Yeah. So this is we're happy with while we talk to people from like all backgrounds. You know, we've had so far we've had a musician on the podcast, and we've had someone who was in the tech neurotech space who's
Sure.
Since moved to San Francisco to
Nice.
really turn the heat up there. We're absolutely craving to get scientifically minded and people of that background to come in and talk to us. So yeah, actually I will divulge this information, but with a bit of luck, we're going to go check out the LIGO,
Sure.
which is up near Gingin, which
Okay.
is just fascinating. Have you heard about that?
No.
Oh, it's incredible. So it's basically this massive facility that has two arms that across the landscape at a right angle to each other, and they send a laser down both arms, and that laser passes through like special glass or silicon that is
Wow.
like suspended with tiny hairs so that you don't get any kind of activity like earthquakes or traffic or any kind of seismic or any whatever activity disturbing the lasers. What the laser does is it travels down and comes back, and apparently the accuracy of this laser, it's a 1 megawatt laser as well. The accuracy of the laser is so significant that it's something like 10 to the power of negative 18. So it's basically the equivalent of if you measured out the distance from here to Alpha Centauri, which is some many light years away from Earth, the accuracy is down to the width of a hair.
Okay.
And what it does is it looks for a disturbance in the lasers as they return back to the center, and it can basically determine that gravitational waves have passed through
Okay.
and dilated the laser. Fascinating.
That's an hour away from Perth.
It's an hour away from Perth, and it is one of only 3 in the entire world.
Wow.
And it's just right there. I mean, I don't know how many people would know about this.
There's a lot happening there's a lot happening in WA.
Yeah.
Yeah, it's fascinating stuff. I mean, Western Australia recently submitted a proposal for obviously they're establishing the Australian Space Agency.
Sure.
And I read a proposal that was recently submitted that was supervised by the chief scientist of Western Australia. And it was basically looking into the capabilities of WA as the sort of the center of the space program, which
There's
is just
a lot of
wow.
potential in this state. A lot of potential.
Yeah. I think a lot of people underestimate just what we have available here in WA. It's, fascinating stuff.
Yeah, those are
Sure.
Victorians.
Don't get it political.
Yeah. Well, I think, we've sort of like smashed through all this. So, yeah. Thank you so much for coming
My
on
pleasure.
the podcast. It's been really interesting, and hopefully, we can pick up some views on this one and
Sure.
and sort of pass out this information because, up until about a week ago, I was oblivious to what was going on, and then found out what you'd done, and
Awesome.
it was fascinating. So
Cool.
yeah, it'd be great to get people to have a listen and learn something new. So
That's fantastic.
yeah, thank you so much for coming
My
on.
pleasure. Thank you for inviting me.
That's all right.
Thanks, guys.
Cheers.
Sure.
Awesome.
Okay.